shell is only big enough for 2 electrons, that is our s orbital. This is our first one. Okay? How many did I say goes in the second one?
6. Oh, 8.
8, right? This is our second one.
Wait.
Okay? I'll explain this in a second. Just
these are the orbitals,
right now we're focusing
right?
on shells, okay?
Oh,
These
shell.
are the electron shells. The first shell has this. Second shell has this, okay? Third shell, fourth shell. All right?
I get it.
Each one of these lines represents a different orbital. So notice, the second shell has 2 different orbitals in it. We have a 2s and a 2p. Okay? We'll talk about that in a minute. So, we start by filling the s orbitals because they're the smallest. So let's take hydrogen, for example. How many protons does hydrogen have?
Hydrogen?
Hydrogen, its atomic number is 1. How many protons does it have? 1. How many electrons does it have? 1. So we're going to start in the first space of 1s. There's 1 electron. Okay? So, wow. That was a complete waste. The way you write this is you write the orbital name, 1s, and then... So frustrating. John, will you hand me a stool?
Give me one too.
Oh my god!
That
John.
A stool.
Alright. So, you write the orbital name, and then in a superscript, or a little number up top, you put the number of electrons that are in that orbital. So for hydrogen, this is its electron configuration. 1s1. Really easy, right? Let's try something like carbon. How many electrons is carbon going to have? 6.
Yes.
Right? 6. So, we take our first 2. They go on the 1s orbital. We have 1 and we have 2. The reason I'm writing these way is because electrons in the same orbital will have opposite spins. So one will spin one way, one will spin the other. So this is just up and down. That's how we configure it. Don't worry about it. Okay? These could just as easily be check marks.
I thought that was a 1.
So 1, 2, 3, 4. So we filled our 1s orbital. Check it off. So now we move on to our 2s orbital. 3, 4. Right? We fill our s orbital first. Now this s orbital is full. The p shell is big enough that it has, or the second shell is big enough that it has a p orbital in it as well. It'll hold the other 6 electrons that an atom needs to make it happy, right? Because we need 8 electrons in our outer shell to make us happy. So we have 1, 2, 3, 4. We filled that s orbital. So now we can move on to our p orbital. 5, 6. Okay? So, the way we would write this electron configuration is again 1s, 2.
Wait, what is it? How do you explain it to?
Name of the orbital, number of electrons in the orbital. So we have 1, 2 in 1s. So we have 1s2, 2s, 2, 2p, 2.
Wait, well, I'm so like, I don't even understand what you're talking about.
That's because you just walked up.
I know. Hang on.
Oh, so 1s, and this is the number of whatever is here?
Exactly.
Okay.
So 1s is the name. The number here is how many electrons are in that orbital.
Do we need to memorize the list like 1s, 2s, 2p, 3s, 3p, 4s, s?
Yeah, we're going to need to know that.
Okay, what is this for? Like configuration?
Yes.
And then what is the S and the P?
Those are the names of the orbitals.
And this is the number of electrons on...
So if 2P has 6, you write a 6 and not a 2.
Exactly. So, let's do that, okay? So 2p is 6. So now we have a full p orbital.
And what is that? Yeah. Why are you putting 1 and then C or whatever?
Because electrons in the same orbital will spin in opposite directions.
So you put like...
So this is how we shorthand it. An up arrow and a down arrow.
Oh, those are arrows?
Yeah, they're like little they're half arrows, right? So it could be like that.
Oh!
Again, these can just as easily be check marks. You're focusing on a very insignificant part of this. Okay?
Okay.
All right. So, what element would this electron configuration represent? How many electrons do we have? Count the superscripts.
8.
9,
Not
10.
10,
10.
right?
I can't even
What
count.
element is that?
Neon.
Neon.
Can't even
Very
count.
good.
Wow.
Okay?
Wow.
Match the atomic number with the amount of electrons. So all you have to do is go to electron number 10. Okay, it's neon. Neon, notice how this shell, this is its outside shell, right? Because that's as far as it goes. Notice that this outside shell is full. Anytime an outside shell is full, we can write it like this.
Oh. Neon.
You can just write it as neon.
What if it's not full?
So if it's not full,
You gotta write it out.
so let's do,
So how much can each orbital
Fluorine.
take?
so now this is fluorine, right? Okay? But, let me show you a quick way to write this. If we have a full s orbital, what element is that?
Helium.
Helium, right? So we can take this out and write helium there. So that's telling you that you have a helium atom plus 2 electrons in the 2s orbital plus 5 electrons in the 2p orbital.
Is it like every P
Well,
is
the
a
fluorine
whole new
has
row?
helium in it?
Exactly. No. A fluorine atom is just like a helium atom, but with an additional 7 electrons and protons. So we can write it this way because this is just looking at electrons. Because when you get down here, you're not going to want to write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and on and on. So, you can use this shorthand of adding the noble gas. So like arsenic, the noble gas of its most full shell is argon, right? So we would write that as argon, 4s2, 3d10, 4p2.
What?
How did you calculate that?
The D's get confusing.
What's helium again? What does it have? It's just.
So what is so okay, so how many is in each orbital?
It depends, right? S orbitals will hold 2 electrons. P orbitals will hold 6 electrons, right? So that when an S orbital and a P orbital get together and make a shell, you have 8 electrons there.
Why isn't there
And d orbitals?
D orbitals they're really hard to understand.
They hold 10.
They hold 10, right? And the shape of them is such that when you get down, this is the D block. Can you hold that up, Yahida?
Yeah.
This is the D block right here. All of
Oh, you wrote on it.
this is the D block, okay? When you get onto these D orbitals, it's always one number less than the row. So for example, this D orbital is 3D, 4P, 3D. Don't worry about why, just know S's and P's go up by 1. The D orbital is always going to be 1 shell number less. So see how down here I have 4s, 3d. So let's try one, okay? Let's do iron.
Oh, whoa, whoa, whoa.
Can we do manganese? Because that's mine.
We just start with
Oh. No?
All right.
I'm oxygen.
We already did.
Okay. How many electrons are in iron?
Where's iron?
How many electrons? Fe.
Oh, 26.
26. All right. So we're going to fill these orbitals from top to bottom, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25.
The last one we did was 25.
25 and 26.
What about that?
That little space
Oh.
right there.
That's where. Wait.
You could have just.
So it has to go. It has to go in that up-down order, right?
That's just how I write it because I know that the spins are opposite.
I have a question.
So can we can
Is this
divide
always
that
the
simple
setup?
gases, right? Yeah.
Like, is this always the setup?
So,
This is how it's always set up, yes.
Oh, and also, so S holds 2, P holds 6, and D holds 8. 10?
10.
Which one holds 8?
8 would be an
S
S
plus a
and a
P.
P together.
Okay.
shell. Yes,
So the next one would be 5S, 4D, 5P.
correct.
Why is it 1S,
Got
2S,
you.
and then 2P? But
Because the shell around S is the one closest to the nucleus, so it's not big enough to contain a p orbital as well. Same thing here.
is that why
The
there's
third
3S
shell?
and then 3P?
Yeah, the third shell isn't big enough for a d orbital, so it goes with the fourth
Then
shell.
why isn't it called 4D? Yeah.
Just 6.
Don't worry about that. That involves. You really want to know?
Yes. Yeah.
Oh, Jesus
No,
Christ, I'm trying to
no.
get
This
to
is
this
what our
workshop.
nucleus, right? This is what our s orbitals look like. Our p orbitals look like this. Our d orbitals will span all of these. Yeah.
Look what you done did.
Span.
It crosses over and covers two orbitals. That's why it's so big and can hold
Why is
10.
it called 3D instead of 4? Oh.
Because it overlaps with the previous shell because it's so big.
So it mixes with 3 and 4, but it's part of
Technically, it's part of the 3D shell, but because
it's so
3
it's
shells.
further out, so it's part
Right.
of 4. Okay.
Right.
That was,
Okay.
That's not that hard.
All right. So, how would we shorthand this? What's the biggest? What's our first shell that is full? 2p is full.
3 P's.
3p is full,
Argon.
right? Very good. So it's going to be. I'm going to hold this up. Argon, and then what's going to come after argon?
Isn't argon AR?
What's going to come after argon? So then we go to our first orbital. 4s.
4S2.
4s2.
3d6.
Yeah. That.
3d6. Perfect.
Oh.
So you see, this saves you from having to write all of this down.
What about the blank spot?
Those are not holding electrons.
So we just put
What are you
equal.
doing with like 7?
What?
We just put equal argon.
No, you don't put, this isn't, argon is all of this
Okay.
up here.
So we
So you have an argon plus a 4s with 2
Why don't we start
electrons.
from 1S?
Why would you use
Okay,
argon?
let me show you
Like,
why.
is that the max?
So it doesn't write.
Yeah.
Because if it's an iron, then that's the last noble gas. I don't know if that makes sense.
You know those things by heart?
I understand.
Straight. I'm getting it, but I don't know what to write down.
This is why we write it for argon. Because all of this is an argon. So it's easier to write the noble gas. Because these are all full shells,
Put them together to make one.
right? Once you get over here, your outermost shell is full.
Are there any other letters that come?
What?
Base it on the atomic.
Get it?
So like right here.
Whatever the noble gas is before that, you can leave out all of that and write the noble gas.
It just means it's going with one orbital.
I have a question. Okay.
It's S, P, D. There's no bigger ones or anything?
Not that we're gonna have to worry about.
Because I know there's an F, I think. There's an F.
Will we ever have to fill up?
F is like way up there.
Yeah, F is like down here.
Don't worry about that. It's just
So if you've got one of those, then I can work with you.
Will we ever have to fill up all of them? Like
I'll give you a piece
more
of
than this?
Depends on what your element is, right? Because this is only for lead. If we get down here,
well, it's not
it's
necessarily.
gonna fill it up. 79 electrons is way more than this.
Yeah.
Oh, you wrote down mine. It's 3D5.
All right, more questions?
Yeah. Okay.
Hold on.
Oh. Okay. How are we gonna know which one it is?
Okay.
Like we just.
So
how do
you
we
can-
know where to stop and be like, oh, I'm gonna use that information and make it that?
So you know that, is this shell full?
Yes.
So that's a helium. Is this shell full?
Yes.
Okay, so that's one. Is this shell full?
Yes.
Is this shell full?
Yes. Except for this one.
So this shell is not full.
Oh wait, this is a shell.
Yeah.
Wait.
So this is all one shell, two
Oh,
shells.
that's why you have the little things. Okay.
So for this one, would it be like 42?
42 electrons.
I'm recording this, so.
I know, I was here.
Oh wait.
So does the pattern go?
What? I haven't done it yet. I've been over here doing this workshop.
Does the pattern go 1S, 2S, 2P, 3S, 3P, 4S, and then
You just have to remember. Yeah, he explained it.
It's because
You want to send that video?
the shell that contains the d orbital is so big that it actually the orbital, the d orbital is so big
At
that
the end
it's
it is.
technically part of this third shell, but it's so big that it lies outside of the shell. So we include it with the fourth shell.
so what comes after 4P?
5s.
Oh, so it keeps
5s,
going.
4d, 5p.
So all of them are going to be at that point.
Well, after that point,
Is everything
Oh, I get it. I see it.
At this point, we drop down here.
That was smart to report the notes.
As an F
so all the D's have 10 of them.
You're going to explain it to me?
Huh?
You're going to help explain it to me?
You can just send you this. Haley, okay. Haley, stop.